Hello, everyone, and welcome to the third session of the massively open online course for the Master's degree of Digital Currencies for the University of Nicosia. This is Andreas Antonopoulos, and in this week's session, I'm going to be answering your questions on the topic of basics of cryptocurrencies based on the collected questions from the last week and your studies. If you have additional questions, please submit them in the YouTube comment section, and we will tackle them one by one. Let's get started. Christopher asks, I still do not understand what happens if there is an attempted double spend. How does the system identify it and deal with it? Well, Christopher, that's a great question. Let's say you have a transaction that is spending a specific output from a previous transaction. Now, that transaction is propagated across the Bitcoin network, where it is stored in the mempool of each node. Now, before a node stores a transaction in a mempool, it's going to look to see whether the referenced inputs in that transaction, the units of value that are being spent by that transaction, have already been spent. If they have already been spent, the network will not propagate that transaction, and it will not be stored in the mempool. Now, how does the network know whether these transactions have been double spent? It looks to see if there is another transaction already in the mempool or already recorded on the blockchain that has spent those same inputs. So the first transaction that propagates will get through the network, will get into the mempool of every node, will get propagated across, will eventually reach miners, and will get included in a block. As it propagates through the network and when it reaches miners, it acts as a blocker, essentially, for any subsequent transaction that would attempt to double spend the same inputs. So another transaction trying to spend the same inputs at the same time will propagate only on those nodes that haven't yet seen the first transaction. Eventually, one of the two transactions will get to a miner and will get included in a block. And as soon as that happens, that permanently closes the door for the other transaction to be propagated and get into a block. The first one that successfully gets into a block spends those inputs, and then they can no longer be spent by another transaction. The only exception is if there is a blockchain reorganization, and the block in which the first transaction was recorded chain. And as a result, all of its transactions get resequenced for processing. Now, that's a pretty rare event. It happens once every 2 days on average, with the accidental simultaneous mining of two blocks on opposite sides of the network that propagate across the network, causing a normal fork, a fork that occurs briefly and is reorganized within one block. So how does the network attempt double spends? By looking for transactions that are spending the same inputs. Philip asks, if I want to exchange item X for Bitcoins, how long does it take until I can see that I've received the Bitcoin and it is inserted into the blockchain? And when do I consider it 100% secure that I now own the Bitcoin and therefore can give out item X to a customer? If, for instance, I have a newspaper stand in the city center and want to sell my newspapers with a high frequency and speed, is Bitcoin a good solution for my business? Could Bitcoin replace cash in this manner? So, Philip, the way Bitcoin works is that when a transaction is propagated across the network, your node will see that transaction fairly quickly. From the moment it's transmitted, a transaction within 5 to 15 seconds is propagated globally. So within 15 seconds at most, if you're a retailer and you are selling an item, you will see an incoming payment for that correct amount. Now, assuming that's a valid transaction, and assuming that transaction has sufficient fee, you have a certain degree of likelihood, that a certain probability, if you like, that that transaction will be mined. The challenge is that there are a number of possibilities where that transaction will not be mined. One possibility is that it doesn't have sufficient fee. The other possibility is that there's a lot of congestion on the network, and the fee is not sufficient for the capacity at the time. And if that transaction doesn't get included, and another transaction with higher fees spending the same inputs is transmitted, it could reverse that payment. Once, however, a transaction is included in a block, the only way that can be reversed is if there is a fork causing a reorganization of the network. Essentially, that block becomes invalidated briefly by not being on the winning chain and gets replaced by another block that gets mined by another miner. In that case, again, during such a reorganization, there is a brief period of time during which a double spend can occur with a higher fee. So the bottom line is, until the transaction has been mined into a block, you can't be certain that it's going to persist. Once it's been mined into a block, you have a much higher degree of certainty that it's going to persist. After 2 confirmations, that degree of certainty increases exponentially. After 3 confirmations, you're looking at an event that happens once every maybe year of a reorganization of 3 blocks. And that is so exceedingly rare, would usually be a reason such as a bug for such a thing to happen. Most users of Bitcoin and retailers would consider 6 blocks degree of certainty, that the probability of doing a reorg is so low that that transaction is effectively irreversible. Now, you don't need 6 confirmations to be certain to sell a newspaper. In fact, I would argue you probably don't even need 1. If you have a transaction that has sufficient fee, the risk of that transaction being invalidated is so low that the price that you're willing to risk, 5 cents for a newspaper, is not worth delaying your customers. You just give them the newspaper, and maybe once a week or once every couple of days, one of those transactions doesn't end up in the blockchain and you lose 25 cents. But you've serviced enough customers during that time that it's more than worth it. It's the cost of doing business. I think the same applies if you're selling a cup of coffee or you're selling another small value retail item where the customer will walk away. Now, if you're selling a flat screen TV, an item worth $1,000 or something like that, maybe you don't want to rely on a 0 confirmation transaction. At that point, you're probably looking at 1 confirmation, which will take, on average, less than 10 minutes. If you can wait for 10 minutes before allowing the customer to leave your store with the TV, you have a fairly high chance that that transaction will be irreversible. A greater chance, in fact, than if you receive that payment with a credit card. Now, if you waited 2 confirmations, then you would have an even greater probability of success. So there is no 100%. The probability decreases at such a rate that you're in the 5 digits, 99.999%, within 3 confirmations. But after that, it never quite reaches 100%. It just approaches it asymptotically. Theoretically, there is a 1 in several quadrillions possibility that the chain gets reorganized all the way back to the Genesis block. The chance of that happening is so low and requires such an extraordinary sequence of events that it's considered impossible in practice. 1 confirmation for a TV, maybe 0 confirmations for a cup of coffee or a newspaper. 3 confirmations for a coffee would be it also calling as 1 confirmation. You can't take it. So I can easily read the deal. If it's a car, away with it, maybe I'm going to wait 6 confirmations, which isn't unreasonable. And do that quite effectively. Jerry asks, experience before transactions are confirmed, what factors are attributed and why does this happen? I sent 0.2 Bitcoin. It took more than 48 hours for confirmation to happen. Before I answer that question, I think maybe the next question will also help us get to this answer. Philip asks, how big is a transaction fee? Who decides it? Is it a percentage? So Philip, I'll start with your question, and then I'll go to Jerry's question. How big is a transaction fee? It depends. The transaction fee is determined by market forces and is calculated on the basis of the size of the transaction in bytes. So it has nothing to do with the percentage, and it has nothing to do with the value that is being transmitted in that transaction. A transaction that exchanges or transfers the value of $1 million, and a transaction that transfers ownership of $1 may be the exact same size. The average transaction, I think the smallest transaction size is about 260 bytes. That's a transaction with 1 input and 2 outputs. If I remember correctly off the top of my head, it's around that, less than 300 bytes. So 1 input, 2 outputs, meaning that you spend a whole amount of Bitcoin, you make your payment to 1 output, and you make your change it to the second output. That's a very common format for a transaction. If it's a multi-sig transaction, it's going to be bigger because the signatures are bigger. If it's a transaction that aggregates a lot of loose change, if your Bitcoin is fragmented across many transactions that are small, and you're aggregating all of those into a larger payment, it's going to have many inputs, and that's going to make it significantly larger. And then the size of that transaction is going to require a higher fee. We generally measure the fee in terms of Satoshis, pardon me, in terms of Satoshis per byte. So for example, let's say the fee is 100 Satoshis per byte. The average fee at which confirmation in 1 block is achieved right now on the network. So transactions are included within 1 block for an average fee of 100 Satoshis per byte. I'm just assuming that's the number. We can look it up and see what it is right now. Now, what would that would mean is if you have a transaction, average size transaction of 300 bytes, you're looking at 30,000 Satoshis, which is 0.0003, if I remember correctly, Bitcoin. So that would be the fee that you need to pay in order to have your transaction included in the very next block, or 1 to 2 blocks from the moment you transmit it. Now, you've got to think of this in terms of market forces. There is a limited number of, there's a limited amount of space on the Bitcoin blockchain. And so fees determine which transactions get in, because miners prioritize transactions that pay more fee. So to answer Jerry's question, sometimes delay is experienced before transactions are confirmed. What factors are attributed to confirmation, and why does delay happen? The answer, Jerry, has to do with supply and demand. There is a fixed supply of capacity on the Bitcoin network. The average block up to 1 megabyte in size can fit, on average, 2,500 to 3,000 transactions, depending on what types of transactions they are, how complex they are, how many inputs they have, how big the signatures are, etc. In order to get into that 1 megabyte block, to outcompete all of the other transactions that are waiting in terms of Satoshis per byte. So if you're a miner, you're looking at your mempool. Maybe you have 5,000 transactions in the mempool, and you've got enough space to put 2,500 of those transactions in the block. So you're going to start sequencing those transactions by sorting the transactions that are in the mempool by those that pay the highest level of satoshis per byte, the highest fee per size they're going to take up in the blockchain, and you prioritize the ones that are most lucrative. So that means that if you put more fee in your transaction, you have a higher chance of having your transaction selected by a miner and sequenced into the very next block. If you put a lower fee in your transaction, then your transaction may not get included in the next block. Maybe it will wait until there are fewer transactions in the mempool. Sometimes when there is a lot of demand, and this happens at the moment several times a month, sometimes several times a week, there are moments of peak use when the mempool is quite crowded. There are many transactions waiting to get into blocks, and the blocks are being produced are full. And so as a result, the competition for fees leads to fee escalation. At that point, if you don't pay sufficient fee compared to what everybody else is willing to pay, your transaction may not be prioritized. And it may take a period of time until the mempool is empty enough for your transaction to get in. For example, 48 hours until you get your first confirmation. If you get your first confirmation, then every block that passes after that, you're going to get additional confirmation. So the delay is only for the first confirmation. After that, additional confirmations come on average every 10 minutes as new blocks come out. The question is, how do you prioritize your fee? Your wallet will do that for you. Many wallets offer an option where you can select whether you want to make your transaction low priority, medium priority, or high priority, and accordingly it will adjust the fees to match that. Let's look at the moment at what fees look like right now. You can review fees. There are a number of services that look at the fees that are evident in transactions in the mempool. One of those is a site called Bitcoin Fees, numbers 21.co, bitcoinfees.21.co. And if we go and look at that, right now we see that the average fee to get into the Bitcoin blockchain in the next block is 220 satoshis per byte, which means that for a median transaction size of 226 bytes, you would have to pay a fee of 49,720 satoshis. And let's see, and that would be, in terms of Bitcoin, your fee would be 4 millibits, or about 50 cents in US dollars, maybe 60 cents in US dollars at the current rate. So that's the cost to include a transaction at the moment. A similar question from Svetlana. She asks, what will be the mechanism to determine the appropriate fees after new coin issuance stops? If the fee determining mechanism is based on the amount of Bitcoins in every transaction, won't it mean that transactions with lesser amount of Bitcoins will stay on the lowest priority and be processed really slowly? So Svetlana, as I just explained, transaction fee, size of transaction in bytes, which has to do with the complexity of the transaction in terms of the number of signatures, the number of inputs. If the Bitcoin you're using comes from many small fragmented amounts or not. The average transaction, about 226 bytes, as we saw. The average fee right now, 220 satoshis per byte. The new issuance of coin stops, which of course is many decades into the future. Miners continue prioritizing transactions by their fees. And at that point, depending on how many transactions are trying to get onto the blockchain, how many transactions can fit in each block, and what people are willing to pay, the market will determine the appropriate fee. Through competition between people wanting to get their transactions into the blockchain. Evangelos asks, please explain which details of each transaction are viewable to everyone. For example, when I read, I send 1 Bitcoin to you, can I see that's in the transaction? No. Evangelos, what you see when you look at a transaction is that a transaction consists of a series of inputs which tell the system which coins are being spent by reference to previous transactions. And so those are associated to specific addresses. So think of it this way. A transaction will say, I'm going to redeem the Bitcoins paid to this address in this previous transaction where they existed as outputs. And here are some signatures proving that I am authorized user of these Bitcoin addresses. I am now going to take the value from those inputs and give it to the following outputs, which again consists usually of Bitcoin addresses. And whatever's left over automatically becomes the fee. So what you can see if you look at a transaction in the public ledger is you can see the inputs and the Bitcoin addresses from where value is coming, and you can see the outputs or Bitcoin addresses where value is going. Not all inputs have Bitcoin addresses, not all outputs have Bitcoin addresses, but that's the most common format of a Bitcoin transaction. There might be more complex scripts. Some of those are expressed in addresses that don't really reveal much about what that script refers to. It might correspond to a multi-signature address or a more complex script. And it's not possible at a glance, certainly, to associate Bitcoin addresses with individuals. There's no information about IP addresses or the owners of these Bitcoin addresses. They're simply numbers. Now, of course, if you already know who owns a specific Bitcoin address, then you can use that information to look at all of the incoming transactions that Bitcoin address, and you can start trying to deduce the activity from that Bitcoin address. But that requires analytics, and you have to actually know which addresses belong to which users. So expanding a tiny bit more on that, Alex asks, could you please explain in more detail the input and output processes? It looks like a single transaction between two wallets creates at least 2 extra transactions with change being sent to the sender and 1 with fees going to the miner. Alex, not quite. So it's important to realize this is not extra transactions. It's extra outputs within a single transaction. So a single transaction has any number of inputs, and inputs are the sources of value, the previous coins that exist on the ledger. So a transaction refers to previous transactions and says, the payments that came in then, I'm now spending those. And a transaction also has outputs, and these create new values on the Bitcoin ledger, which can be spent in the future as inputs by another transaction, which creates more outputs, which can be spent as inputs by another transaction, which creates more outputs, and so on. So every transaction takes as inputs the outputs of a previous transaction and creates outputs of its own. What are the outputs? The outputs are chunks of Bitcoin, a specific value, maybe 0.0001 Bitcoin. They're actually measured in Satoshis. So internally in the system, everything is an output may be 200,000 Satoshis or 2 million Satoshis. And as a result, these outputs create this value on the ledger that is associated with a specific address or other script for redeeming this value. So a transaction will create an output, let's say 2 million Satoshis, that can be redeemed by whoever has for Bitcoin address X output. The person you're trying to pay, the merchant you're buying a cup of coffee, or friend you're sending Bitcoin to. They only have one output. If the amount you're trying to send is precisely what you have in your wallet at the time in exact change plus fee, then maybe your transaction has one input, one output. Those are relatively rare. Most transactions have one input, two outputs. One input that consumes a value that is larger than what you want to pay. One output that pays the exact amount you want to pay, let's say sending money to your friend. And one output that returns change for the remainder back to another address owned by your wallet. Somewhere in there are the fees, but the fees are not an output. The fees are simply the remainder between the inputs and outputs, the difference. So if you consume 1 Bitcoin as input, you give out half a Bitcoin in one output and 0.49 Bitcoin in the other output, then there's 0.01 Bitcoin that's unaccounted for, that's not counted in the outputs, that was not consumed by the outputs. That becomes the fee. So anything left over where the inputs exceed the outputs is the fee by implication. Fees are not explicit in Bitcoin transactions. They never appear as one of the outputs. The average transaction has two outputs, one for your payment, one for your change. They can be in any order. You can't always tell which one is the payment and which one is the change unless you know who owns these addresses. And some transactions don't have change because the input happens to be the exact size of what you want to pay plus fees. Alex asked, when I create a new transaction from my Bitcoin wallet, can I add a text message to the recipient? Would this message become part of the digital signature and also be encrypted by SHA-256 into a hash? If yes, what is the maximum length of such a message? Would it be possible for the recipient to view it? Alex, no, you can't put messages per se, text messages, into a Bitcoin transaction. Explorers allow you to put a message related to a transaction, but that's not stored in Bitcoin. It's simply stored in the database of that company to associate some information with a transaction. It's a voluntary thing, and who knows if that database is going to be around in the future. There are some limited ways to include a small amount of information, 80 bytes, in a special type of output called a data output or op return. That is outside of the scope of this. This certainly doesn't fall on the basics of cryptocurrency. It's an advanced feature. That is not used to send text messages to the recipients of Bitcoin. It's used to encode metadata for various overlay protocols. We'll talk about that in subsequent chapters of the MOOC when we discuss colored coins, counterparty, and other layered technologies that operate alongside or above, if you like, Bitcoin. That's the only way you can encode data within a transaction, or that's the clean way of encoding data within a transaction. There is no way to add a text message to a transaction that a recipient can view. If you see a service like that, it's offered by a company. They store the information in their own database. It really does violate your privacy to do that. And the recipient may never see it because unless they're looking at the transaction in the specific company's website, that message will not be on the blockchain. Let's see what else we have. Jinjing asks, in your recent talk about the 2 layers of protection against quantum computing, you mentioned that the best practice of Bitcoin is to only use an address once, spend it completely every time, redirect the change to a new address. As a new Bitcoin user, I'm very confused by this. Could you help me understand how this is done, please? I thought any change is returned automatically to my Bitcoin wallet, which provides the new address generated from my seeds without my intervention. Jinjing, that's absolutely correct. So in fact, your wallet is already doing the best practice. It's using every address only once, is generating a new address for each transaction, is generating a new address to receive coins for every time you receive and give someone else a Bitcoin address. And when you send Bitcoin to someone, it uses all of the Bitcoin in an input and redirects to change from that address to a new change address, not reusing addresses for the most part. I'm guessing, because I don't know what wallet you have, but from what you described, if your wallet is generating new addresses for every transaction, it most likely does the best practice of only using an address once. These types of wallets are called hierarchical deterministic wallets, or HD wallets. Typically, they're the type of wallets where you back up your wallet by writing down a series of 12 to 24 words as a seed, the word you used in your question here, and generating new addresses, deriving them from a specific seed is the best practice. So your wallet is already doing this. You don't need to do anything special. In fact, users don't have the ability to control this behavior. The only way you control this behavior, the way you achieve the best practice of using an address only once, is effectively by choosing a wallet that is well designed and protects your privacy. So your choice is not how the transaction is constructed. Your choice is to use a wallet that does this well. In fact, there are a number of projects that look at the privacy implications of different wallets and rank them to see whether they leak information, how they construct transactions, whether the transactions are constructed in such a way as to not reuse addresses, whether they're constructed in such a way as to not reveal which addresses that change, and various other things like that. The Bitcoin Privacy Report, Open Privacy Report, in fact, is one such project that looks at the relative practices of different wallets and ranks them, telling you which wallets you should use for best privacy. Jinjing also asks, you stated that in the creation of a Bitcoin address, the data that is converted to base 58 is a concatenation of the key hash and an address version number. What is this address version number? Who decides which numbers to choose from? The address version number is a prefix that goes into the base 58 encoding that determines what the first few digits of the address will look like. And this is by design. Every cryptocurrency uses a different prefix so that the addresses can be distinguished. For example, Bitcoin's default is a prefix of, I believe, well, I think it was 0. And as a result, the base 58 encoding of this prefix is the number 1. So Bitcoin addresses start with 1. Addresses that encode multi-signature or complex scripts, addresses we call pay-to-script hash, start with a 3. You may have noticed the multi-signature addresses start with a 3. That's because the version number chosen to do base 58 encoding of those types of addresses is different, and is designed to produce a 3 as the first digit. Other cryptocurrencies may use different address formats, so they start with other letters. If I remember correctly, Litecoin uses a prefix that makes every address start with an L. On the Bitcoin testnet network, every address starts with a lowercase m. And again, all of these effects, if you like, are created by choosing a address version that produces a different pattern when encoded in base 58, so that the first 1, 2, or 3 digits of the base 58 address spells something that helps the user understand what type of address this is. And accordingly, the software that uses the address can interpret what type of address it is and encode it accordingly. So no need to worry. All Bitcoin addresses that start with 1 have the same address version prefix. All Bitcoin addresses that start with a 3, that means a script, have the same one. All of the ones on testnet have the same, etc., etc. You don't need to handle that. Your wallet does it for you. And let's see, I think that covers all of the questions in this particular series. Let's see if we have any additional questions from the chat room. Yes, we do. Can a mining pool that pays its respective members make them exempt of fees? Yeah, sure. A mining pool could basically mine transactions with 0 fees. They can choose to include transactions with any fee they want. Of course, the demand for transactions with 0 fee or very low fee is near infinite, or at least it's very large. There is demand for thousands of transactions to be included at low fees. It's only when the fees are higher than 0 that that demand is somewhat constrained. If the fees are close to 0, there are more transactions than can fit in the network. In fact, if you think about it, what you see in the mempool today is only a fraction of the possible transactions that people might want to be transmitting. Relay transaction fee encoded in the Bitcoin core software and in nodes, which means that transactions that include less than 1/100th of a millibit do not default node to node. So there's already a minimum fee just to cross the network. There are certainly perhaps thousands of transactions that I'd like to do with 0 fees that would never get propagated because they don't fulfill this minimum relay. Anything that's below immediately. Just the stuff that already into blocks can able to send fees. They're simply to fit all of and storing the fees and the priority to achieve great work. Now, cases of a virus blockchain. Question. Not the blockchain itself, simply because the blockchain itself is an emergent system that comes from thousands and thousands of different systems all checking each other. You can have a virus affecting a specific node and making that node behave in a peculiar manner. But of course, if it does that, all of the other nodes will stop trusting it, or rather will stop connecting to it because they don't trust it to start with. Every node validates everything it gets from every other node and doesn't trust any other node on the network. You assume when you're running the software, your software assumes that all other nodes cannot be trusted and does verification on its own. So a node that has a virus and behaves in a peculiar manner will basically get cut off. In fact, much more mild behavior, minor bugs, will be interpreted as abnormal behavior and will get your node banned from the network. So a virus can't really affect the blockchain itself, because even if it affects the behavior of one node, it will just end up causing that node to be isolated from the rest of the network. Why was the max amount of Bitcoin ever to be created set at 21 million? Why not 1 billion? Why not any other number? So the answer is simple. 21 million is exactly half of 42 million. 42 is the answer to the question of what is life, the universe, and everything, according to Douglas Adams' Hitchhiker's Guide to the Galaxy. 42 is the answer. I'm not being serious, of course. That's a joke. There is really no reason why 21, 42, or any other number would work. It's an arbitrary number because if you think about it, a unit of 1 Bitcoin or 100 million Satoshis is itself an arbitrary number. What matters is how much value that represents, and that's determined by market forces. If you said that the maximum number of Bitcoin was 1 billion, it wouldn't change anything. It would simply mean that the current valuation, 1 Bitcoin would be worth a lot less than it is now, because there would be more of them. And if there were less of them, they would be worth more. But in the end, it doesn't really matter. The value of the entire market is determined by market forces. And the unit, how you measure something, really doesn't matter. Why is a kilo a kilo? Why is a meter a meter? Why is a pound weigh as much as a pound weighs? It doesn't matter. If you change the units, it doesn't affect the system. Is there any benefit to becoming a node in the Bitcoin network? Becoming a node requires resources: broadband connection, storage, electricity, connectivity issues, etc., etc. That's a great question. Yes, there is a very good reason why you would run your own Bitcoin node. It is so that you don't have to trust any third party in order to determine exactly what is happening with every transaction. If I want to know if I have been paid on the Bitcoin network, I have two options. I can run my own node, and then my own node, through its software, can independently verify the entire blockchain and every transaction and give me an authoritative answer without asking anybody else, through its own verified blockchain, and say, yes, that transaction has happened. It is being confirmed 3 times. You have been paid. That is an authoritative answer I can only have from my own node. The alternative is to ask somebody else. I could ask a Bitcoin service on a website. I could load a blockchain explorer. I could have my wallet connect to other nodes and ask them if a transaction has been confirmed. But when I do that, I am trusting that other party. I'm trusting that website. I'm trusting that other node to tell me the truth. It might not tell me the truth. And so trusting in third parties is not what Bitcoin is all about. Bitcoin is about not trusting in third parties, but being able to independently verify and validate the state of the system yourself. And the only way you can do that is by running a node. Now, that takes resources. In the last 2 versions of Bitcoin Core and the Core Network software, from version 12 to where we are today, which is almost with the release of version 0.14, the resources required for a Bitcoin node have been greatly optimized. The implementation of better cryptographic libraries like lib, SecP256K1, has made the validation, the initial validation of the blockchain 7 times faster if you use the same hardware as it was back in V012 of the software. Also, you now have the option to prune the blockchain, which means that once you validate it from the Genesis block until today, which takes quite a bit of disk space, you can then discard the old transactions. They're only used once for validation, and then you don't need to store them forever. By discarding older transactions that are not relevant and pruning the blockchain, you can still operate a fully authoritative full validation node, but you don't need 115 gig or 120 gig of disk space to store all of the information from the blockchain. You can also limit the number of connections you have to the network and the amount of information you transmit and bandwidth you transmit on the network. So you can limit your bandwidth, both inbound and outbound. You can also limit the size of the mempool by essentially pruning the mempool too. So you can run a Bitcoin node on hardware with not very much storage, hardware with not very much RAM, and hardware with not very much bandwidth. Of course, You do have slightly more limited functionality, but you can still authoritatively validate all of the information. I run my own full node. In fact, I run several full nodes on different systems with different infrastructure requirements. Some of them not just fully validating, but with a full copy of the blockchain, the entire historical record, and the ability to serve other nodes. And that consumes a lot of bandwidth, and it costs probably $20 or $25 a month in resources and electricity. I use a hosting provider to do that. I also run a fully validating node on my own hardware, and that is a fully validating node, but it doesn't use as much bandwidth, as much memory, and as much disk because I can't afford to carry that around. So you can run your own node, and there are good reasons to do it. What time does Bitcoin system use? I believe time is fundamental to keep synchronizations of node and health of the distributed ledger. How is time managed and kept in sync with the world? Is that part centralized, or does it rely on the network connection? What an excellent question. Bitcoin uses standard internet time conventions in terms of expressing time in the form of Unix epoch timestamps, meaning measuring time in seconds since January 1st, 1970, which is a convention used across the internet for most systems that use time. Your clock on your laptop is synchronized with other clocks around the world using that convention of time. So time is recorded in terms of seconds. That time is measured from a specific point in time, and that's stored in usually a 32-bit or 64-bit integer. But beyond that, the time is synchronized with other servers using a protocol called NTP, Network Time Protocol. And this has nothing to do with how Bitcoin operates. This is simply how computers on the internet ensure that their clocks are relatively in sync with each other and not deviating dramatically. Your laptop does that to keep the computer clock accurate. Your smartphone does that to keep its own clock accurate. You can use various sources of time in order to increase the accuracy. Perhaps if you're doing something very, very time sensitive, you might use a very accurate time source like a GPS receiver that uses the atomic clocks on GPS satellites, or an atomic clock itself. That's how you get time onto your local node. But how does the Bitcoin system itself use time? Well, the Bitcoin system will assume that any block that comes in must be valid only within a certain time tolerance. It can't be too far in the past. It can't be too far in the future. It's assumed that you won't be perfectly synchronized with the time of the rest of the network. Your clock might be off, or the clock of the miner who created the block might be off. So the timestamp of an incoming block is compared against your local clock, and there is a certain tolerance there for a small deviation during which the block will be considered valid. Once a block is recorded onto your own blockchain and you construct your blockchain, then there is an additional meaning of time, which was recently implemented, called median time passed, or MTP. Median time passed is, in fact, the measure of Bitcoin consensus time across the network. And it is used as the basis for determining whether transactions which have time locks, check lock time verify, check sequence verify, end lock time, and end sequence time locks, are valid or not. And the way that's done is under the consensus rules. The median time from the timestamps of the last 11 blocks is taken, and that median time is used to estimate the validity of time-locked transactions. Now, as you can imagine, median time passed, 11-block average looking into the past, that means that median time passed is approximately 1 hour behind actual time. So, for example, right now, the time where I am is almost 9 p.m. Median time passed on the network at this time is 8 p.m. my local time, or whatever that is in UTC time zone. So as a result, median time passed is the consensus rule time used for validating time lock transactions. Time is a really interesting concept in Bitcoin, and there are layers and layers of how you answer that question. All right, one last question. Is Bitcoin a currency? Is Bitcoin a commodity? Is Bitcoin a store of value? If you store Bitcoin long-term in the belief that the price will appreciate in the future, then you're using it as a store of value, but that makes it a very poor currency because you're unlikely to buy anything with it. People are reluctant to spend Bitcoin if they think that the price will go up in the future. If you spend it and use it as a currency, does it still have good value as a store of value in the long term? And the other aspect of that question is it a problem that this is a deflationary currency? What is the reasoning behind the idea? So that's a great philosophical question. The deflationary nature of Bitcoin certainly will make people more likely to hold their Bitcoin than spend it. Now, in Western societies, we call that hoarding. In many Eastern societies, they call that saving. And the difference is whether you have a consumer mentality towards money or a long-term mentality towards money. Different cultures look at savings in different ways. I don't think hoarding is a problem necessarily, and my personal experience with Bitcoin is that it has made me a better saver. And yet, I still use it as a currency, even though I use it as a long-term store of value and use it for my savings. So I think you can do both. I do. And you take the volatility and the potential loss of value due to deflation as part of that. Why is Bitcoin a deflationary currency? The primary reason is because Bitcoin was conceived as, if you like, a response to the exactly opposite approach that you see in national currencies, where inflation in many cases is rampant. But even if it's not, even if inflation is within the targets of central banks, those targets imply a 2% annual inflation, which means that in 20 years, your money is worth half of what it is today. That's inflation operating over a long time scale, and that means money continuously loses its value. Bitcoin is designed to be more like digital gold, and as a result, it's designed to keep its value or even appreciate in value vis-a-vis national currencies that are inflating. That necessarily makes it a better store of value than a day-to-day currency, but it doesn't make it impossible to use as a day-to-day currency. It just is more in the nature of a long-term store of value. Of course, it's difficult to determine these things in advance, and we'll see how the market plays out and what it will use Bitcoin for. A lot of people theorize that Bitcoin will be used increasingly as a reserve currency, and that other systems, perhaps other technologies, other cryptocurrencies, or other layers within Bitcoin will be used more for high velocity, small value transactions, and not on-chain Bitcoin itself. We'll see how it goes. All right, and I think that completes all of the questions we had from this week. Now remember to study the material for next week, talk with your colleagues and the other students, exchange ideas on the forums, and start sending us questions as soon as you have them so we can curate all of these questions. I'll see you in a week when we'll have session 4, massively open online course on digital currencies for the master's degree at the University of Nicosia. This is Andreas Antonopoulos. It's been a pleasure answering your questions. Great questions as always. Thank you so much for sending them, and hope to see you next week. Take Take care.